Okay, so we're doing extraneous solutions today. I probably could have projected this, but I wanted to handwrite it because it makes me happy, and this is extraneous solutions. So what we're going to be doing is we're going to be simplifying radical expressions as well as solving them in equation form. Do you want me to say that again?
Yes.
Yeah.
We're going to solve equations with radicals. Okay?
Okay.
Okay. So the first thing I want to do is I want to get the square root of 5 minus x by itself, but it's tied up with that -3. How can I get that -3 over to the other side?
Add 3 on both sides.
Yeah, I'm going to add 3 on both sides once I find a pen. So I'm going to add 3 to each side. So now I've got the square root of 5 minus x equals 3. What's the opposite of square rooting?
Squaring.
Squaring. So in order to get rid of this radical, I'm going to square all the things.
Square like everything?
Yeah, but that just drops out the stuff inside of the radicand. The radicand is not touched. And then I can subtract 5 on each side. And then divide by -1. And x equals -4. I think. I should know, but the way to know is to do a check. In this unit, you completely have to do a check. You really don't have a choice. You must do a check. You don't have an option. And it works.
Wait.
Yeah?
2 negatives.
I just realized how many markers you have.
Yep.
So when you do the check, does it not matter if it's the square root?
Well, the square root of 9 is 3, and 3 minus 3 is 0.
Oh.
Yeah.
I don't get the check.
I literally just replace x with -4. So 5 minus -4 is 9. Square root of 9 minus 3 is 0. And that works. Do 2 and 3 without me. Go. Okay, so on the first one, I added 3 to get the radical by itself. I squared it, and I got 64, and then I checked it. On number 3, I squared everything, I subtracted 8, and I checked it. What do you guys think we're going to do first?
Get in on the left side.
Nope, we gotta deal with that radical. What do you think? Yeah, let's square everything. And you're gonna see something really weird happen. Get ready for flashbacks, y'all.
Oh no.
What
Oh
kind?
yes, we're going all the way back to notes to a factoring and FOIL. That was like a month ago. Oh, my necklace is backwards. Okay, so now I need to get this equal to 0.
Oh.
Oh no, and then I need to factor it using GCFs. Oh my gosh, this is notes too. A factor FOIL. Oh my gosh, and then I get to use the 0 property, which is notes 9 of factor FOIL.
If we just did.
Let it ride. So I think these are my answers, but I have to check. Have to check. So the square root of 4 times 0 equals 0. It does. The square root of 4 times 4 equals 4. It does. So my answers are n equals 0, n equals 4.
Wait, so how much?
I'm going to pause to keep writing. Okay, so the x equals root 10x answers is 0 and 1. Everyone worked on that one. Now this one, this is where things get a little bit more weird. And this is weird, where the weirdness is going to be heading. So everyone brace yourself for the weirdness.
Braced.
2 people brace themselves. That's awesome. Okay. So first things first, I've got the radical by itself. So I'm going to square everything.
Nice.
So I've got x plus 10. The radicand drops out. But as a reminder, even though you should all know it, okay, x plus 4 squared is not x squared plus 16.
Oh. Wait,
Oh.
why? Well, it's not in parentheses though, is it?
Yeah.
What? Wait.
If you need help figuring out what this is, please refer back to notes 3 of factoring and foiling.
Oh,
No,
is
go
it-
back. I'm not telling you how to do this. I'm not going to let Lily answer
Oh, I
either.
know what it is.
No, you have to know how to do this. Pause. Okay, so we've had 2 tests since then. X plus 4 quantity squared is x squared plus 8x plus 16. And now what we're going to do is we're going to get the whole side equal to 0. Is everyone with me?
Yes.
I can solve that by using either the double distributive method, the box method, or FOIL. Notes 3.
How do we get that?
Yo, I
Notes
love Marco.
3, Mama. I know. I couldn't find
Okay,
notes 3.
so I'm going to subtract x from each side. I'm going to subtract 10 from each side. So now I have x squared plus 7x plus 6 equals 0. Now at this point, I have 2 options. I can either factor this, which is factor FOIL notes 5, or I can quadratic formula this, which is notes 12.
Either.
So we have options. But I can just look at this and be like, factors of 6 that add up to 7.
6 and 1.
And then I get to use the 0 property, which is notes 9 of factoring and FOIling. So x plus 1 equals 0, x plus 6 equals 0. So x equals -1, x equals -6. And then we're going to pause again to make sure everyone's caught up because this is about ready to get super weird. Okay. Okay, so we're gonna do our checks, and over here, my check, well, it looks pretty good. So it looks like the square root of 9 is 3. But whenever I come over here and I do a check, well, the square root of 4 is plus or minus 2, but I got -2 only. So that seems kind of weird. And what's going to happen is we have to go back to the very beginning. And whenever we look at parabolas, not parabolas, Lily.
No.
Lily.
That's what I'm.
All right, so what we have is we have a parabolic shape. But if we look at the parent function of a square root symbol, what we actually have is we have half of a parabola on its side starting at 0. Now here's the question. Why doesn't this graph occur in any other of the quadrants? Because it's positive. Because we can't take the square root of a negative number. Does this make sense?
Yes.
Well, we can, it's just not real. Okay, so now let's actually look what's happening in our graph. So if in your y equals screen of your calculator, it's probably still there. If you go back to the very beginning and you graph y equals x plus 4 and y equals the square root of x plus 10, look at all the setup I did for this one problem. I mean, just saying, I'm like killing it as a teacher, just saying. In case you haven't noticed, like, you are going to graph the square root of x plus 10, and you're going to graph x plus 4.
How do you just say graph after that?
Uh-huh.
X plus 10
Minus
plus 4.
No, you have to have the square root up here.
Yeah.
Man, I got it.
Your graph should look something like mine.
Yeah.
And when you're done, stare at me intently. Okay, so if we look at -1, -1 does indicate an intersection between these two lines. And I can very clearly see, like, that is an intersection. But -6 doesn't intersect with x plus 4 up here. But if this graph was going to continue, it would have intersected here. But that stupid square root sign is kind of getting in the way. It should be more like curved, but you know, whatever.
Nobody's
Excellent.
perfect.
Well, good thing that's
Besides
not a person.
Mrs. Brown.
I am clearly perfect. I mean, look at me. I am perfection incarnate. Have you not seen the miraculousness of my mathematics? I'm clear.
Uh,
Perfection is 5'2" and neurotic. Thank you. Okay, so let's look at this. So this -6 should indicate an intersection, but the square root sign, the radical, is what's getting in the way. So x does not equal -6. X only equals -1, and this is an extraneous solution. It kind of should have sort of existed, but it actually doesn't. And we can see that with our check that this doesn't work. And this is what my graph is looking like. So once again, if you've got two functions and you're setting them equal to each other, like this, you're really tracking the intersections. So if, let's say, you were on the state test and it's asking for the if it just gives you this, and is asking for the solution, you could punch it into your calculator, hit second, trace 5, and trace the intersection and call it a day. If it's asking for the extraneous solutions, though, you actually have to go back through and do math to find the -6. Does this make sense?
Yes.
Okay, cool. I want to make sure.
If we increase the graph size, would it still would it show?
No, it never will.
Oh.
Do number 7 without me. 1, 2, 3, go. Just as a side note, if you don't want to factor it, you can always use the quadratic formula if it equals 0. So you could, after you square it and you get one side equal to 0, your A term would be 1, your B term would be 1, and your C term would be -110. And you can always do the quadratic formula. I don't know why you wouldn't. I never said you couldn't. So why wouldn't you? Because it's delightful and amazing, and it's just everything good and happy in this world, and there's an annoying song to go with it, so why wouldn't you? Pause. Okay, so all my students are standing upright in the back. So I factored it, I did the zero product property, which is notes 9, and then I figured out that 10 works, -11 doesn't. So what I would write on my answer line is I would be like, n equals 10, n does not equal -11, and then I'd be like, extraneous solution. Okay, cool. And then all my little dumplings are going to go back and they're going to work on this one. And it's going to be amazing and so glorious. And they're going to 1, 2, 3, go. Buddy.
Hey, do you want us to put -2?
My students are currently discussing -2 squared if it's 4 or -4.
Because when I put on the calculator,
come
it
on,
get negative.
guys.
I get -4 in parentheses.
Negative times a negative is a positive.
You have to put it in parentheses.
Oh, my B.
Parentheses, -2. Finish the parentheses.
No.
and Squared.
Okay.
Otherwise, it's just think you're doing 2 squared with a negative.
Evan?
So what's nice though about this moment is that while some kids are freaking out, other kids are freaking out at the kids freaking out and stating, hey, you put the -2 in parentheses. That way you're doing -2 squared, because otherwise your calculator thinks you're doing 2 squared but make it negative. Not to steal the words directly out of one of my students' mouths, but it's pretty awesome that I've got students yelling at other students to like figure out how to do parentheses. So that's pros and cons there. So that's pretty entertaining. Okay, so let's talk about this. So whenever I square both sides, I get 4 equals x minus 5. I can add 5 to each side and get 9 equals x. But whenever I plug it into my check, my solution doesn't work out because the square root of 4 is plus or minus 2, but I only got -2. If I look back at my graph, I've got my root function, which is this kind of like shark fin shape, but then y equals -2. And how many times do those lines touch?
0.
They don't. Yep.
Didn't we just figure that out by plugging the things into the y equals 3?
Yes, we can
Yeah.
do that. but you
Yeah,
need
we
to
could do that.
That's what you get.
But you have to prove it.
You have to prove it. Now, that's for me. The state test doesn't get to see any of your glorious work that's going to be so nice, neat, and organized on your paper. So once again, if it's just asking like, hey, what's the solutions? Type it into your calculator, second, trace 5, call it a day. Some people are shouting that they were doing the quadratic formula. Just so much more work. I don't know about you guys, but mathematicians are lazy, and I am. Yeah.
So why did we put no soul instead of
Extraneous solutions.
Yeah.
I mean, we could write that if you wanted to. I mean, we could say
Are
X.
they interchangeable? Like we can do either.
Well,
right?
if you say x does not equal 9, then you need to tell me it's an extraneous solution.
That's what I did.
It's brown.
But no sol and extraneous solutions, I mean, kind of the root word here is extra.
Well, because you need extra to get.
Exactly.
But we can't put x does not equal 9, no soul.
You could write that, yeah.
Okay.
That would be acceptable. All right, now real quick, I'm going to start this one for you guys. Now here's what you cannot do. If you notice that there's a radical, two radicals on one side of the equation, I can't just square the whole thing because you're going to lose a piece. So instead what I want to do is I want to write plus root x plus 4 plus root x plus 4. And now I've got x squared minus 2 equals the square root of x plus 4. Yep. And now I can square everything. And whenever I subtract x from each side, and I subtract 4 from each side, I get that. Now, let's say I forgot about that rule, and I just squared both sides of the equation. I'm going to do this in blue, and I'm going to do it wrong. So let's say I square everything. Well, then I've got x squared minus 2 minus x plus 4 equals 0, which is x squared minus x plus 2 equals 0.
That's not right.
Well, that's not right. And that's because this minus sign is being applied to everything. And you would need to recognize those parentheses. I mean, you could do it, I'm not sure how many 8th graders would remember to do that. So instead, get a radical on both sides of the equation, get the radicals by themselves, and then try and do your math. And then we'll give all my dumplings a couple of minutes to catch up and finish this problem and hopefully figure out if x equals 3 or if x equals negative 2, and we're going to see what happens. Quickly cruising out of time, I decided to factor. I use the zero property to do that. I do my checks, both of them work out. So my answers are x equals 3, x equals negative 2. You do have homework tonight. Good luck, it's 5 problems, and yes, you have to do the challenge.
Wait, where's the homework?